Hello, and welcome to my continuing series dealing with Lewis Carroll's most difficult problems. These problems require that you be proficient in the field of logic. Because I'm dealing on an advanced level with problems that have been unsolved. This problem will be in part 2 of this book, Symbolic Logic, edited by Bartley. I recommend you get this book if you're interested in these problems. There are many, many difficult problems that are more difficult than most of the modern problems in logic. These books are available used quite cheaply. Here's a summary or synopsis of what I'll be doing today. I'll be showing to you my complete method for solving these problems. What I recommend you do, rather than me reading each line, go ahead and pause your video and you read it. Go ahead and pause and read ahead. I'll move this on down so you can keep reading and pausing as you see fit. That's the overview of what I'll be doing today. Here's that problem on page 386 of the book I just mentioned. This is problem 1. This is probably his second most difficult problem. It remains unsolved. I will show you how I solved it using my methodology by programming in Power Basic. So go ahead and read the problem. As before, pause and I'll scroll down. Again, I recommend that you get this book if you're interested in these problems. I'll be discussing again this problem in more detail shortly after you have a look at it. Go ahead and pause as you see fit. It takes me just a bit to get through because there are 50 statements. This is what makes it difficult. There are all the 50 statements you've just seen. Now I'll be going to the coding I've used. Carroll would call this the dictionary for this problem. It is not quite the same as the one in the book, but you'll be able to figure it out. Again, I'll go on down and you can pause and you can read. What you can do is take screenshots of these if you want to refer back and forth to the problem and the dictionary here and what I'll be discussing in the program to follow. So there it is, going back up. Here's that program in Power Basic. It works by running a large number of different trials, with each trial starting with random initial values for each of the 52 attributes. Each trial consists of iterative loops which are stopped when either a successful run is found or a set number of loops is reached. A successful run is when a loop is found with all 50 statements being true, so that would be one solution. There can be a large number of solutions, with each solution consisting of a unique combination of attribute values. The key to this process is that each problem statement can change the value of one or more attributes. After this process of attribute alteration, each of the 50 problem statements are evaluated as true or false. If all 50 statements evaluate as true, then each attribute is recorded as present or not present, or we could say true or false, or 1 or 0. This iteration process is quite rapid and powerful as compared to the brute force method, which would entail running all 4.5 times 10 to the 15th combination of attributes. When constructing the register of attributes for this problem, I found 3 retinands, AA, LL, and KK. I'll show you how those were used in this program. This is the start of the program. We'll be running 1 million trials. Start initially by assigning each attribute a random value of 0 or 1, as you see here. Here we start a loop for iterations. Note that I've set AA equal 1, KK equal 1. I found that trying various combinations of the 3 retinands, that this combination would produce a value of LL equals 0 for all good runs, as you will see. Going on down, here are the problem statements. There'll be 50 of them. There you go. Here's where we do statement testing, right here. Summation and printing out below. Let's go ahead and run that program. Here's that output. This program will run in just a few seconds. Note that out of 1 million trials, we got 413,000 plus good trials. Sums for each attribute are given. The summary of our results is right here. Interpreting these, we get the conclusion, or the problem solution, which is, my London friends that are novelists are young. That's my solution, and that's all for today.